In the early morning hours of December 2006, 1913, the tallest railroad terminal in the world opened its doors to the public in Detroit, Michigan. Michigan's Central Station stood 18 stories above street level, its Beaux-Arts concourse rising beneath a vaulted ceiling modeled on the great Roman bathhouses, its office tower designed to house railroad administrative functions for generations yet unborn. The facility was engineered to process thousands of passengers daily across multiple trunk lines connecting the industrial Midwest to eastern markets and beyond. Every design decision embedded within its limestone facades and marble corridors assumed a single, unexamined premise: that railroad passenger traffic would continue expanding indefinitely, that the centrality of rail to American commerce was permanent, and that the monumental scale of the structure would be justified by perpetual growth. The station performed precisely as intended during its early decades. Trains arrived and departed on schedule. Passengers moved through grand waiting rooms and descended to platform level through passages designed for efficient crowd flow. The building fulfilled its role within a transportation network that had dominated American commerce for nearly a century. Yet within 60 years of its ceremonial opening, the terminal would stand abandoned, its windows systematically shattered, its interior infrastructure cannibalized for salvage value, its ornamental plaster exposed to Michigan winters. By the 1990s, Michigan Central Station had become an international symbol of American urban decay, a ruin as evocative as any ancient temple, photographed endlessly by urban explorers and architectural historians seeking to document what remained of a vanished era. This is not a story about vandalism, though vandals certainly contributed to the building's deterioration. It is not a story about neglect, though decades of deferred maintenance accelerated every failure mechanism. It is not even primarily a story about the decline of railroads, though that decline provided the essential context for everything that followed. This is the story of how a design philosophy, the assumption of perpetual growth embedded in physical structure, created a building that could not survive the conditions its own success was meant to guarantee. When the assumptions encoded in Michigan Central's scale, cost structure and revenue model ceased to hold, no subsequent owner could escape the trap that the original designers had unknowingly constructed. The station was not destroyed by any single decision or catastrophic event. It was destroyed by the gradual, relentless operation of physical processes that the building's design had no mechanism to resist. How does a structure engineered for permanent relevance become structurally incapable of surviving the very future it was built to serve? The answer begins not with the building's abandonment in 1988, nor with the railroad bankruptcies of the 1970s, nor even with the rise of automobile competition in the decades following World War II. The answer begins in 1910, when the architects and engineers of Warren and Wetmore, in collaboration with the engineering firm of Reed and Stem, sat down to design a terminal that would express the ambitions of the New York Central Railroad and its Michigan Central subsidiary. The design decisions made in those drafting rooms, decisions about scale, materials, revenue structure, and operational logic, would determine the building's vulnerability thresholds for the next century. Understanding Michigan Central's failure requires understanding what those designers believed they were building and why those beliefs proved catastrophically misaligned with the world that actually emerged. The Michigan Central Station that opened in 1913 was not merely a passenger facility, it was a complex institutional machine designed to accomplish multiple simultaneous objectives. At the most basic level, the station needed to process the flow of passengers, baggage, and mail between trains and the city of Detroit. This functional requirement drove the design of the ground-level concourse, the underground baggage handling systems, the platform arrangements, and the pedestrian circulation patterns that connected street level to track level. The architects studied passenger flow data from existing terminals, consulted with railroad operating departments, and designed a facility capable of handling projected traffic volumes with appropriate margins for growth. But the station was also intended to serve as a symbolic statement about the New York Central Railroad's presence in the Midwest. The New York Central had long competed with the Pennsylvania Railroad for dominance of the Eastern Trunk Line market, and that competition extended to architectural expression. When the Pennsylvania Railroad announced plans for its monumental Pennsylvania Station in New York City, a structure designed by Ems, Kim, Mead and White to evoke the grandeur of the Roman baths of Caracalla, the New York Central responded with its own architectural program. Grand Central Terminal in New York, designed by the same Warren and Wetmore firm, would become the New York Central's flagship statement. Michigan Central Station in Detroit represented an extension of that architectural philosophy to the railroad's western operations. The symbolic program influenced every aspect of the station's design. The waiting room was conceived not merely as a functional space for passengers awaiting trains, but as a civic monument comparable to the great public buildings of European capitals. The ceiling height, the quality of materials, the ornamental program featuring classical motifs and allegorical figures, all of these design choices prioritized symbolic expression over operational efficiency. A purely functional station could have been built for a fraction of the cost. But the New York Central was not building a purely functional station. It was building a cathedral to the railroad age, a structure that would communicate permanence, stability, and institutional confidence to every passenger who passed through its doors. The most consequential design decision, however, involved the 18-story office tower that rose above the station's head house. This tower was not an afterthought or a speculative addition. It was integral to the station's financial logic. The architects understood that a monumental passenger station by itself would generate limited direct revenue. Ticket sales and concession income could not justify the construction and maintenance costs of a Beaux-Arts palace. The office tower was designed to solve this problem by creating a secondary revenue stream. Railroad administrative offices would occupy significant floor area, paying internal rents that would be accounted against the station's operating costs. Additional space would be leased to outside tenants, law firms, insurance companies, and other businesses that benefited from proximity to the railroad and its commercial connections. This revenue diversification strategy appeared sound in 1910. Office space in downtown Detroit commanded premium rents, and the tower's location adjacent to a major transportation hub seemed to guarantee tenant demand. The New York Central's own administrative needs would provide a stable base of occupancy, while market-rate tenants would generate additional income to offset maintenance costs. The tower transformed Michigan Central Station from a pure cost center into a mixed-use development capable, at least in theory, of financial self-sufficiency. What the designers did not recognize, what they could not have recognized, given the assumptions that governed their era, was that this revenue diversification strategy created correlation risk rather than genuine hedging. The office tower's financial performance was structurally linked to the health of the railroad industry. When railroad traffic declined, administrative staffing would decline with it, reducing the internal tenant base. When the railroad industry's prestige faded, the tower's attractiveness to outside tenants would fade as well. The diversification strategy assumed that railroad fortunes and Detroit real estate values would move independently. In fact, they would prove deeply correlated, and both would decline together. The station's physical design compounded this economic vulnerability through its maintenance cost structure. The Beaux-Arts architectural program specified materials and finishes that required specialized craft labor to maintain. The ornamental plaster ceilings, the marble wall surfaces, the bronze fixtures and hardware, the terracotta exterior ornament. Each of these elements demanded periodic attention from workers with skills that were becoming increasingly rare, even as the station opened. A plasterer capable of repairing ornamental moldings was not interchangeable with a plasterer who installed drywall. A bronze conservator who could properly maintain the station's decorative metalwork required years of specialized training. As long as the railroad remained prosperous, these skilled trades could be retained or contracted as needed. But the moment financial pressure emerged, specialized maintenance would be among the first expenses deferred. The building's scale amplified every maintenance challenge. The waiting room's vast interior volume required heating systems capable of moving enormous quantities of air. The tower's height demanded elevator systems, window washing equipment, and facade inspection protocols far more complex than those required for a conventional mid-rise building. The underground baggage handling areas, designed for expansion, created infrastructure that would need to be maintained whether fully utilized or not. Fixed costs, heating, elevator operation, basic security, structural maintenance remained largely constant, regardless of how many passengers actually used the station. When traffic declined, per-passenger costs would rise, creating a financial death spiral that the building's design had no mechanism to interrupt. Perhaps most critically, the station was designed with no provision for graceful degradation. The architects conceived of Michigan Central as a permanent monument, a structure that would serve the same function in perpetuity. They did not design for partial operation, adaptive reuse, or systematic contraction. There was no way to close the tower while keeping the station operational, no way to reduce the waiting room's footprint while maintaining passenger services, no way to mothball portions of the building during periods of reduced demand. The station was designed as an integrated whole, and it could only function as an integrated whole. When that integrated operation became financially unsustainable, the only options were continued full-scale operation at mounting losses or complete abandonment. The building's design contained no middle path. The infrastructure assumptions embedded in Michigan Central extended beyond the building itself to its relationship with the surrounding urban fabric. The station was sited in what was then the southwestern edge of Detroit's developed area, approximately 2 miles from the traditional downtown core. This location reflected several strategic calculations. Land costs were lower at the urban periphery, allowing the railroad to assemble a larger site at reduced expense. The site provided room for the extensive rail yard throat required to serve multiple platform tracks, and the location assumed that Detroit would continue growing outward, eventually surrounding the station with dense commercial and residential development that would generate additional passenger traffic. This assumption proved partially correct during the station's early decades. The Corktown neighborhood surrounding Michigan Central developed as a working-class residential area, while the Michigan Avenue corridor connecting the station to downtown became an important commercial strip. But the pattern of growth that the designers anticipated, continued concentration of economic activity in the urban core, with transportation infrastructure serving as an organizing framework, would be fundamentally disrupted by the automobile. The same city that gave birth to mass automotive production would be transformed by its own invention as population and economic activity dispersed along highway corridors to suburban locations inaccessible by rail. The station's site, carefully selected for its relationship to the rail network, would become increasingly peripheral to the automobile-oriented city that Detroit was becoming. By the time Michigan Central Station opened in December 1913, the design premises that would eventually destroy it were already embedded in its limestone foundations. The building assumed perpetual growth in rail traffic. It assumed that a monumental architectural program could be maintained indefinitely through the revenues generated by that traffic. It assumed that office tenants would always value proximity to railroad operations. It assumed that specialized craft skills would always be available for maintenance and repair. It assumed that Detroit's urban development would continue to favor centralized transportation infrastructure. It assumed that the building would never need to operate at reduced capacity or adapt to changed circumstances. None of these assumptions were unreasonable in 1910. All of them would prove false within 50 years, and the building's design provided no mechanism to survive their falsification. The question that would haunt Michigan Central Station for the next century was already latent in its architectural drawings. What happens to a building designed for permanence when the conditions that justified its scale cease to exist? The designers had created a structure of extraordinary physical durability, The reinforced concrete frame, the masonry cladding, the quality of materials and construction methods all ensured that the building would remain structurally sound for generations. But physical durability is not the same as institutional viability. Michigan Central Station was designed to resist fire, earthquake, and the ordinary weathering of time. It was not designed to resist the slow withdrawal of the economic and social conditions that gave it purpose. That vulnerability, invisible in 1913, would become the central fact of the building's existence as the 20th century unfolded. The New York Central Railroad, like all major American railroads of its era, had developed institutional practices optimized for a specific type of asset management. Railroads were, first and foremost, transportation companies. Their core assets were rolling stock, locomotives, passenger cars, freight cars, and the infrastructure that supported train operations, track signals, bridges, tunnels, and the specialized equipment required to maintain them. These assets demanded constant attention. A locomotive required regular inspection, lubrication, and component replacement. Track needed continuous monitoring for gauge, alignment, and rail condition. Bridges required structural assessment and preventive maintenance to avoid catastrophic failure. The railroad industry had developed sophisticated systems for managing these operational assets, with detailed inspection protocols, maintenance schedules, and capital replacement programs that reflected decades of accumulated experience. Railroad stations occupied an ambiguous position within this institutional framework. They were necessary for operations. Passengers needed somewhere to purchase tickets, wait for trains, and transfer between rail and street transportation, but they were not operational assets in the same sense as locomotives or track. A delayed locomotive maintenance could cause a derailment. Deferred track work could result in speed restrictions or service interruptions, but a station with peeling paint or a leaking roof could continue functioning after a fashion for years or even decades. The consequences of deferred station maintenance were primarily aesthetic and reputational rather than operational. This distinction shaped how railroads allocated their limited maintenance resources. The New York Central's maintenance budget allocation reflected these institutional priorities. Operating departments, mechanical, engineering, transportation, received funding based on formulas tied to train miles operated, tonnage moved, and equipment utilization rates. These formulas had been refined over decades to ensure that operational assets received attention proportional to their use. Station facilities, by contrast, were funded through general administrative budgets that competed with other overhead expenses. When financial pressure emerged, station maintenance was among the first categories to experience cuts because such cuts did not immediately threaten train operations. Michigan Central Station, despite its architectural grandeur, was subject to these same institutional dynamics. The building was carried on the railroad's books as a fixed asset, depreciated over time according to standard accounting practices. But the depreciation schedule bore no relationship to the building's actual maintenance requirements. Ornamental plaster does not deteriorate on a linear schedule. Bronze fixtures do not require replacement at predictable intervals. The building's maintenance needs were driven by physical processes, weathering, material fatigue, accumulated wear that operated independently of accounting conventions. The gap between depreciation accounting and actual maintenance requirements created a structural tendency toward underinvestment that would compound over decades. The specialized nature of Michigan Central's construction exacerbated this institutional bias. The ornamental plaster ceilings in the waiting room were not standard construction elements that any competent contractor could repair. They were custom artisanal work, executed by craftsmen trained in techniques that dated to the Renaissance. When sections of ornamental plaster cracked or delaminated, repair required workers who understood the specific composition of the original materials, the techniques used to apply them, and the methods required to match existing work invisibly. Such workers existed in 1913 when the building was completed. They were considerably rarer by 1950. By 1970, finding craftsmen capable of proper ornamental plaster repair required national searches and premium compensation. The railroad's institutional structure provided no mechanism to retain or develop these specialized skills. Craft workers were hired on a project basis when specific repairs were required. There was no apprenticeship program to train new plasterers in ornamental techniques, no knowledge management system to preserve information about the building's original construction methods, no career path that would encourage skilled workers to maintain expertise in increasingly obsolete crafts. Each generation of maintenance workers knew less about the building's specialized requirements than the generation before. Knowledge that had been commonplace in 1913 became rare by 1940 and virtually extinct by 1970. Similar dynamics affected every specialized system within the building. The bronze hardware and fixtures throughout the station required periodic cleaning and preservation treatment to prevent corrosion and maintain their appearance. Proper bronze conservation involved specific chemical treatments, protective coatings, and handling techniques that differed fundamentally from ordinary metal maintenance. The terracotta exterior ornament, the decorative elements that gave the facade its distinctive character, required inspection for cracking, assessment of anchor conditions, and specialized repair techniques when damage was identified. The marble surfaces throughout the interior needed cleaning methods appropriate to their specific geological composition, along with periodic sealing and polishing to maintain their appearance. Each of these maintenance requirements involved specialized knowledge that the railroad's institutional structure was not designed to preserve. The building's mechanical systems presented different but equally challenging maintenance problems. The heating plant, designed to warm the enormous interior volumes of the waiting room and office tower, was a complex system of boilers, steam distribution piping, and terminal units that required specialized operating knowledge. The elevator systems serving the 18-story tower were early examples of high-rise vertical transportation with control systems and safety mechanisms that became increasingly obsolete as elevator technology evolved. The electrical systems, installed when electric power distribution was still a relatively new technology, used materials and methods that later generations of electricians would find unfamiliar. Operating and maintaining these systems required institutional knowledge that existed in the minds of long-tenured employees, rather than in documented procedures. As the railroad's workforce contracted through the middle decades of the 20th century, this institutional knowledge dissipated. Senior mechanics who had operated the heating plant since the 1920s retired without transferring their understanding of the system's quirks and vulnerabilities. Electricians who knew the idiosyncrasies of the original wiring left the company without documenting what they had learned through decades of troubleshooting. The building became increasingly opaque to those responsible for its maintenance, a physical artifact whose inner workings were no longer fully understood by anyone still employed to maintain it. The broader trajectory of the railroad industry accelerated these institutional failures. The New York Central, like most American railroads, experienced mounting financial pressure from the 1950s onward. Competition from automobiles, trucks, and airlines eroded both passenger and freight traffic. Regulatory constraints limited the railroad's ability to adjust pricing or abandon unprofitable routes. Labor agreements negotiated during the industry's prosperous years created cost structures that became unsustainable as traffic declined. The railroad's response, inevitably, was to reduce expenses wherever possible. Maintenance budgets were cut. Capital investment was deferred. Workforce reductions eliminated positions that had provided institutional continuity. Michigan Central Station felt these pressures acutely. As a passenger facility in an era of declining passenger traffic, the station was an obvious target for cost reduction. The waiting room that had once processed thousands of passengers daily now served hundreds. The elaborate infrastructure designed for peak operations sat idle most of the time, accumulating maintenance needs that would not be addressed. The office tower, intended to generate revenue that would offset station operating costs, struggled to attract tenants as the railroad's prestige declined and suburban office parks offered newer facilities with better parking. The revenue diversification strategy that had seemed prudent in 1910 was failing on both dimensions simultaneously. The Penn Central merger of 1968 represented a desperate attempt to salvage the failing Northeastern Railroad industry by combining the New York Central and Pennsylvania railroad systems. The merger was catastrophically mismanaged, combining two incompatible corporate cultures with incompatible operating systems, incompatible equipment, and incompatible labor agreements. The resulting organization lurched from crisis to crisis, hemorrhaging money while failing to achieve any of the operational synergies that had justified the combination. Within 2 years of the merger's completion, Penn Central would file for bankruptcy, at the time the largest corporate bankruptcy in American history. The bankruptcy transformed deferred maintenance from a financial expedient into formal corporate policy. A bankrupt railroad operating under court supervision had neither the resources nor the legal authority to undertake discretionary improvements. Every expenditure required justification in terms of immediate operational necessity. Station maintenance, which had always struggled to compete with operational priorities, became virtually impossible to fund. The Penn Central bankruptcy trustees were focused on preserving the railroad as a going concern, keeping trains running, maintaining essential infrastructure, meeting payroll, not on preserving the architectural heritage embodied in facilities like Michigan Central Station. The Conrail transition of 1976 brought federal intervention to the failed Northeastern railroads, combining Penn Central's remains with other bankrupt properties into a government-sponsored entity. Conrail's mandate was to restore freight railroad service to the region while minimizing ongoing federal subsidies. Passenger operations were explicitly excluded from this mandate. Amtrak, created in 1971 to assume responsibility for intercity passenger rail service, would operate trains over Conrail's tracks but would not own or maintain the station facilities that served those trains. Michigan Central Station fell into an institutional gap, neither a freight asset that Conrail was responsible for maintaining, nor a passenger facility that Amtrak would invest in upgrading. Amtrak's relationship with Michigan Central was that of a tenant, not an owner. Amtrak paid fees for the use of station facilities but had no obligation or incentive to invest in their long-term preservation. The portions of the station that Amtrak actually used, the platform areas, the ticketing facilities, minimal waiting room space, received enough maintenance to remain functional. The remainder of the building, including the tower and most of the grand architectural spaces, was simply closed off and allowed to deteriorate. The waiting room that had once welcomed passengers with soaring ceilings and marble walls became a partitioned shell, its ornamental features hidden behind temporary walls that defined the minimal spaces Amtrak required. The office tower, meanwhile, had lost its last tenants. Railroad administrative functions had been consolidated elsewhere as the industry contracted. Outside tenants, who had once valued proximity to the railroad, found the building's declining condition and the neighborhood's changing character increasingly unappealing. By the 1970s, the tower stood largely empty, its 18 stories of office space representing a massive liability rather than a revenue source. The maintenance costs required simply to keep the tower weathertight exceeded any conceivable rental income. The revenue diversification strategy that had been central to the station's original financial logic had become a mechanism for accelerating losses. The physical condition of the building reflected these decades of institutional neglect. The roof, last comprehensively maintained during the railroad's prosperous years, had developed numerous failure points where water penetrated to the interior. The windows, original single-glazed wood sash units, had deteriorated to the point where many no longer operated properly, and some had failed entirely. The heating system, operated intermittently and maintained minimally, could no longer reliably warm the building's vast interior volumes. The ornamental plaster showed extensive cracking and water damage. The bronze fixtures were tarnished and corroded. The marble surfaces were stained and dull. Every element of the building that had once expressed the railroad's confidence and prosperity now expressed instead the industry's decline. The institutional context that had created Michigan Central Station had also created the conditions for its destruction. The railroad's maintenance protocols, developed for operational assets, systematically underinvested in architectural preservation. The specialized knowledge required to maintain the building properly was never institutionalized and gradually dissipated. The financial pressures affecting the entire railroad industry made discretionary expenditures on passenger facilities impossible. The corporate restructurings, merger, bankruptcy, government intervention, fragmented responsibility without creating any entity charged with the building's long-term preservation. By the time Amtrak operated its last train from Michigan Central Station in January 1988, the building had already been neglected for decades. The closure of passenger service did not cause the station's deterioration. It merely removed the last restraint on processes that had been underway since the 1950s. The human factors that enabled this institutional failure operated at multiple levels. Individual maintenance workers, faced with impossible workloads and inadequate budgets, made rational decisions to prioritize urgent operational needs over long-term preservation. Department managers, measured on short-term performance metrics, deferred discretionary maintenance to meet budget targets. Senior executives, struggling to keep failing companies solvent, cut expenses that did not immediately threaten train operations. Government regulators, focused on transportation policy rather than architectural preservation, did not require railroads to maintain historic stations to any particular standard. Each actor in the system behaved rationally given their constraints and incentives. The cumulative result was catastrophic for the building. The training that railroad employees received reinforced these institutional biases. Operating personnel were trained extensively in the rules and procedures governing train movements. The safety-critical knowledge that prevented accidents and kept trains running on schedule. Maintenance personnel received training in the specific skills required for their job classifications: track work, electrical systems, mechanical equipment. No one received training in architectural preservation or historic building maintenance. No one was taught to see Michigan Central Station as a cultural resource requiring specialized stewardship. The building was simply infrastructure, an overhead expense to be minimized, not an asset to be preserved. The incentive structures governing railroad management created additional pressure against preservation investment. Railroad executives were evaluated on financial performance, return on assets, operating ratio, earnings per share. Investment in maintaining an aging passenger station generated no measurable return. Such investment actually worsened short-term financial metrics by increasing expenses without corresponding revenue gains. A rational railroad executive, operating within the incentive framework established by shareholders and boards of directors, would minimize expenditure on facilities like Michigan Central Station. The institutional design of American corporate governance actively discouraged the kind of long-term preservation investment the building required. The regulatory environment provided no counterweight to these market-driven pressures. The Interstate Commerce Commission, which regulated railroads during the period of Michigan Central's decline, was primarily concerned with rates, routes, and service levels. Building condition was not within its jurisdiction. State and local regulators had limited authority over railroad facilities and even more limited enforcement capability. The historic preservation movement, which gained momentum during the 1960s and 1970s, created new legal frameworks for protecting significant buildings. But these frameworks focused primarily on preventing demolition, not on requiring adequate maintenance. Michigan Central Station was eventually listed on the National Register of Historic Places, but that listing created no obligation for the railroad to invest in its preservation. When Amtrak announced in late 1987 that it would relocate Detroit passenger service to a temporary facility, the decision reflected a rational assessment of the options available. Michigan Central Station required extensive rehabilitation to continue serving passengers safely and comfortably. Amtrak lacked the capital to undertake such rehabilitation and had no mandate to preserve the building's architectural character. A temporary facility could provide adequate passenger service at far lower cost. The decision to leave Michigan Central was not vandalism or neglect. It was the logical conclusion of institutional processes that had been operating for decades. The building had become an orphaned asset, and no institution existed with both the responsibility and the resources to preserve it. The closure of passenger service in January 1988 marked the end of Michigan Central Station's functional life, but the institutional failures that had brought the building to this point had been accumulating since at least the 1950s. The design premise of perpetual railroad growth had failed, the revenue diversification strategy had failed, the maintenance protocols had failed, the knowledge preservation had failed, the corporate governance had failed, the regulatory oversight had failed. Each failure was individually explicable. Collectively, they ensured that by the time passenger service ended, Michigan Central Station was already a building with no viable future. The last Amtrak train departed Michigan Central Station on January 5, 1988, carrying passengers to Chicago through a winter evening that offered no particular ceremony or commemoration. The train was the Wolverine, the same service that had connected Detroit to Chicago for decades under various names and operators. Passengers who boarded that evening experienced the same journey their predecessors had experienced countless times before, the same route through southern Michigan, the same stops at Ann Arbor and Kalamazoo and other intermediate stations, the same arrival at Chicago's Union Station. What distinguished this particular departure was not anything the passengers experienced, but what happened after they left. When the Wolverine cleared the station throat and accelerated westward toward its first stop, Michigan Central Station ceased to function as a transportation facility. The building that had processed millions of passengers over 75 years became, in that moment, simply a vacant structure awaiting an uncertain future. Amtrak's decision to relocate Detroit passenger service reflected an accumulation of factors that had made continued operation at Michigan Central increasingly untenable. The station's physical condition had deteriorated to the point where basic passenger amenities could no longer be reliably provided. Heating systems that had struggled for years finally failed during the harsh winter of 1986-87, leaving passengers waiting for trains in spaces that could not be adequately warmed. Plumbing systems, original to the building and unmaintained for decades, failed with increasing frequency. Electrical systems designed for 1913 loads could not reliably power the equipment required for modern ticketing and communications. The platform areas, exposed to weather and neglected for years, presented safety concerns that temporary repairs could no longer address. The building's structural systems remained fundamentally sound. The reinforced concrete frame that Warren and Wetmore's engineers had specified in 1910 was designed to last centuries and showed no signs of imminent failure. But a structurally sound building is not necessarily a habitable one. The secondary systems that made the building functional for human occupancy, mechanical, electrical, plumbing and envelope systems, had deteriorated beyond the point where incremental repair could restore adequate service. Comprehensive rehabilitation would have required investment measured in tens of millions of dollars, capital that Amtrak neither possessed nor could justify spending on a facility serving declining passenger volumes in a city whose population had been falling for decades. The temporary facility that replaced Michigan Central Station was located approximately 3 miles to the northeast, on the edge of Detroit's New Center district. The facility occupied a modest structure that offered none of the architectural grandeur of the abandoned terminal, but provided the basic amenities that passengers required. a heated waiting area, functional restrooms, a ticket counter, and convenient access to platforms. The move represented a frank acknowledgement that passenger rail service in Detroit had contracted to the point where a monumental station was no longer necessary or sustainable. The temporary facility was adequate for the several hundred daily passengers who continued to use Amtrak service. Michigan Central Station had been designed for thousands. The physical transition from occupied to vacant status occurred with remarkable speed. Within weeks of the last departure, the station's remaining operational systems were shut down. The heating plant that had warmed the building's enormous interior volumes was deactivated. Electrical service was reduced to minimal security lighting. Water service was discontinued to prevent pipe failures in the unheated structure. The building was not formally mothballed. No comprehensive protocol was implemented to protect interior spaces from the consequences of vacancy. The station simply ceased to operate, and no one assumed responsibility for managing the transition from active use to long-term preservation. The consequences of this unmanaged vacancy began manifesting almost immediately. Michigan winters subject buildings to thermal stresses that occupied structures rarely experience. Interior spaces that had been maintained at comfortable temperatures for 75 years suddenly experienced the full range of Michigan's continental climate. Temperatures that might reach 90 degrees Fahrenheit in summer dropped to well below zero in winter. This thermal cycling affected every material in the building differently. Plaster, which had remained stable in the controlled interior environment, began experiencing differential expansion and contraction that accelerated existing cracks and created new ones. Wood elements throughout the building, window frames, doors, trim, structural blocking, absorbed moisture during warm periods and experienced frost damage during cold ones. Metal components corroded as condensation formed on surfaces that had never before experienced temperature swings of this magnitude. The building's envelope, which had adequately protected interior spaces during occupied operation, was poorly prepared for the demands of vacancy. The original windows were wood-framed single-glazed units, designed for an era when heating fuel was cheap and thermal performance was not a design priority. Many of these windows had already failed through decades of minimal maintenance. Some had been replaced with plywood or other temporary coverings. Others remained in place but no longer sealed properly against weather infiltration. When the heating system was deactivated, these compromised windows became pathways for moisture and temperature extremes to reach interior spaces. The roof presented similar vulnerabilities. The original roofing systems had been replaced at least once during the building's operational life, but the replacement work had been performed under the budget constraints of a declining railroad. Proper roof maintenance requires regular inspection, prompt repair of minor failures, and comprehensive replacement when systems reach the end of their service life. Michigan Central's roof had received none of these interventions. By 1988, the roof membrane had numerous failure points where water could penetrate to the structure below. During the building's occupied period, these leaks had been identified and patched when they caused interior damage. With the building vacant, there was no one to notice leaks and no reason to repair them. The first winter of vacancy demonstrated the acceleration of deterioration that uncontrolled conditions could produce. Water that penetrated through roof failures and window gaps collected in interior spaces with no drainage path to the exterior. When temperatures dropped, this water froze, expanding and creating mechanical stress on surrounding materials. When temperatures rose again, the ice melted, releasing water to migrate further into the building fabric and collect in new locations. This freeze-thaw cycling is the dominant deterioration mechanism for masonry and concrete structures in Great Lakes climates. It occurs approximately 100 times per year in southern Michigan, each cycle propagating existing damage and creating new damage points. The ornamental plaster that had been one of Michigan Central's most distinctive interior features proved particularly vulnerable to freeze-thaw damage. Plaster is a porous material that readily absorbs water. When saturated plaster freezes, the expanding ice disrupts the material's internal structure. Repeated cycling progressively weakens the plaster until it loses cohesion and falls from the substrate. The waiting room ceiling, which had survived 75 years of occupied use with only minor deterioration, experienced catastrophic failure within a few years of vacancy. Huge sections of ornamental plaster fell to the floor below, destroying irreplaceable artisanal work that had taken skilled craftsmen months to execute. The bronze fixtures and hardware that remained in the building after closure became targets for salvage within months of vacancy. Security presence had been reduced to occasional patrols after passenger service ended, and the building's scale made effective monitoring virtually impossible. Salvagers recognized that the station's bronze elements had significant scrap value and were relatively easy to remove. Door hardware, light fixtures, railings, decorative panels, anything that could be pried loose and carried out was systematically stripped from the building. This salvage activity caused direct damage to the elements removed and collateral damage to surrounding materials. It also created additional breach points in the building envelope, accelerating moisture infiltration and thermal cycling. The windows, both those that remained intact and those already compromised, became targets for vandalism. The station's prominent location and iconic status made it a destination for urban explorers, photographers, and less benign visitors. Breaking windows provided both access to the interior and, for some visitors, a form of destructive recreation. Each broken window created a new pathway for weather infiltration. Wind-driven rain could now penetrate deep into the building's interior, reaching spaces that had been protected since construction. The cumulative effect of window destruction was to progressively eliminate the boundary between interior and exterior, subjecting the entire building to weather conditions it had never been designed to resist. The tower's 18 stories amplified every deterioration mechanism affecting the building. Wind speeds at the tower's upper levels significantly exceeded those at grade, increasing pressure on window openings and driving moisture through any available crack or gap. The tower's height created a stack effect that drew air through the building, carrying moisture and temperature extremes from exterior to interior. Water that penetrated at upper levels migrated downward through the structure, damaging multiple floors as it traveled. The tower's prominence also made it a particular target for vandalism, as broken windows at high levels were more visible and more difficult to secure than those at grade. The building's structural concrete, which had provided the stable framework for 75 years of operation, began experiencing deterioration processes that would eventually threaten structural integrity. Reinforced concrete of the type used in Michigan Central's construction relies on the high alkalinity of cement paste to protect embedded steel reinforcement from corrosion. Over time, carbon dioxide from the atmosphere penetrates concrete surfaces and reacts with cement compounds, gradually reducing this protective alkalinity through a process called carbonation. The carbonation front advances slowly, typically less than a millimeter per year in high-quality concrete, but over decades can reach the depth at which reinforcement is placed. When carbonation reaches reinforcing steel, the steel loses its corrosion protection and begins to rust if moisture and oxygen are present. Rust occupies significantly more volume than the steel it replaces, creating expansive forces within the concrete. These forces cause the concrete cover to crack and eventually spoil off, exposing additional reinforcement to corrosive conditions. The process is self-accelerating. Initial corrosion causes damage that allows faster moisture penetration, which accelerates further corrosion, which causes more damage. By the time Michigan Central Station was vacated, carbonation had been advancing through its concrete for 75 years. The building's exposure to uncontrolled moisture during vacancy provided the final condition needed for active corrosion to begin. The exterior terracotta ornament that gave the building's facades their distinctive character experienced parallel deterioration. Terracotta is a fired clay product, inherently porous and susceptible to water absorption. When water within terracotta freezes, the resulting expansion can crack the material. These cracks allow additional water penetration, leading to more severe freeze damage in subsequent cycles. Terracotta elements are typically attached to building structures with metal anchors that corrode when exposed to moisture. As anchors corrode, they expand, cracking the terracotta from within. They also lose strength, eventually failing and allowing terracotta elements to fall from the building. The falling of architectural elements from Michigan Central's facades created both safety hazards and additional deterioration pathways. Each piece of terracotta or stone that separated from the building left an opening in the weather envelope. Each opening allowed additional moisture infiltration. The building's height made facade deterioration particularly dangerous. Elements falling from upper stories could fall hundreds of feet before striking the ground, posing severe risks to anyone in the vicinity. The safety hazards created by facade deterioration would eventually require the installation of protective fencing around the building's perimeter, isolating it further from any possible productive use. The building's interior continued deteriorating along multiple simultaneous pathways throughout the 1990s. Floor finishes failed as moisture penetrated from above and below. Wall surfaces delaminated as plaster and paint lost adhesion to substrates. Metal elements corroded, staining adjacent surfaces with rust. Wood elements rotted, particularly at locations where moisture accumulated. Biological growth, mold, mildew, and eventually vegetation established itself in spaces that had become de facto exterior environments. Each passing year added to the accumulation of damage, increasing the scope and cost of any eventual rehabilitation. The rate of deterioration followed a distinctly non-linear trajectory. During the building's occupied years, deterioration had occurred gradually, checked by maintenance interventions that addressed problems before they could cascade. Vacancy removed these checks, allowing small problems to propagate into large ones without intervention. A minor roof leak that would have been patched within days during occupied operation could grow for years during vacancy, causing damage to multiple floors and multiple building systems. The cumulative effect was deterioration that accelerated over time. Each year of vacancy caused more damage than the year before, as existing damage created conditions enabling additional damage. By the mid-1990s, Michigan Central Station had transitioned from a building that needed rehabilitation to a building that needed comprehensive reconstruction. Systems that had been repairable in 1988 were now beyond repair. Materials that had been salvageable were now destroyed. The building retained its structural frame and its basic form, but the interior finishes, mechanical systems, and significant portions of the exterior envelope had been lost. The divergence between the building's potential and its condition had widened into a gap that no conventional development approach could bridge. The station's trajectory from closure to ruin had followed physical laws as predictable as gravity. Remove heating and a building experiences thermal cycling. Remove envelope integrity and moisture penetrates. Remove security and vandalism occurs. Remove maintenance and deterioration accelerates. Each of these consequences followed inevitably from the decision to close the station without implementing preservation measures. No malicious intent was required to produce the outcome. No unusual circumstances intervened. The building simply experienced the natural consequences of vacancy in a harsh climate, without any institutional force acting to prevent or mitigate those consequences. The divergence between the building's physical reality and any plausible future use widened with each passing season. Rehabilitation cost estimates, which had been challenging but potentially manageable in 1988, grew by several percentage points annually as additional damage accumulated. The gap between rehabilitation cost and achievable development value, already present at closure, expanded continuously. By the time any serious rehabilitation effort might be attempted, the building would have deteriorated to a point where only extraordinary investment could save it. The closure of passenger service in January 1988 had initiated a countdown. not to any specific catastrophic failure, but to the point at which preservation would become economically impossible through conventional means. The physical processes that govern Michigan Central Station's deterioration operated according to principles that materials, scientists, and structural engineers had understood for decades. Concrete carbonation, steel corrosion, freeze-thaw cycling, moisture migration, biological colonization. Each of these mechanisms had been studied extensively and was well documented in technical literature. What made Michigan Central's deterioration distinctive was not the novelty of the processes involved, but their scale, their interaction, and the absence of any intervention to interrupt their progression. The building became in effect an uncontrolled experiment in the long-term behavior of early 20th century construction materials under conditions of total neglect. Reinforced concrete of the type used in Michigan Central's structural frame represented a relatively mature technology by 1910. The fundamental principles, steel reinforcement embedded in a cement aggregate matrix to create elements capable of resisting both compressive and tensile stresses, had been developed in the mid-19th century and refined through decades of practical application. American engineers had constructed major buildings, bridges, and industrial facilities using reinforced concrete, accumulating experience that informed the design standards applied to Michigan Central structure. The building's frame was designed conservatively, with safety factors that reflected both the engineering knowledge of the era and the institutional caution of designers working with relatively new materials. The concrete mix design, specified for Michigan Central, reflected best practices of the period. Portland cement, the binding agent that gave concrete its strength, was produced to standards that ensured reasonable consistency. Aggregate selection followed established guidelines for gradation and cleanliness. Water-cement ratios, though not as precisely controlled as modern practice demands, were kept within ranges that produced adequately strong and durable concrete. The resulting material was dense, reasonably impermeable, and highly alkaline, conditions favorable for protecting embedded steel reinforcement from corrosion. The initial protection that concrete provides to reinforcing steel depends on the high pH environment that cement hydration creates. Fresh concrete has a pH of approximately 12.5 to 13, a level of alkalinity that maintains steel in a passive condition where corrosion cannot initiate. This protection persists as long as the alkaline environment surrounding the steel remains undisturbed. The threat to this protection comes from two primary sources: chloride ion penetration, which can disrupt steel passivity even in highly alkaline conditions, and carbonation, which progressively reduces concrete alkalinity until the protective environment no longer exists. Michigan Central Station, located inland and not exposed to marine environments or extensive de-icing salt application during its operational life, faced limited chloride exposure. Carbonation, however, proceeded continuously from the moment the concrete was placed. Carbon dioxide from the atmosphere dissolves in pore water within concrete and reacts with calcium hydroxide, the primary source of concrete's alkalinity, to form calcium carbonate. This reaction is slow but relentless, advancing from exposed surfaces into the concrete interior at rates determined by concrete permeability, ambient humidity, and carbon dioxide concentration. The carbonation rate in typical structural concrete of Michigan Central's era was approximately 0.05 to 1 millimeters per year under normal exposure conditions. Reinforcing steel in the building's structural elements was typically placed with cover depths of 25 to 40 millimeters, depending on element type and location. Simple arithmetic indicates that carbonation fronts would reach reinforcement depths sometime between the 1940s and the 1980s, depending on specific local conditions. The building's occupied status during this period limited the consequences of carbonation reaching reinforcement. Interior humidity was controlled, moisture intrusion was addressed through maintenance, and the conditions necessary for active corrosion were generally absent. The transition to vacancy fundamentally altered the corrosion risk equation. Moisture that had been excluded by functioning envelope systems now penetrated freely throughout the structure. Humidity that had been controlled by operating mechanical systems now fluctuated with exterior conditions. The steel reinforcement in carbonated concrete, which had remained passive in the relatively dry conditions of occupied operation, was now exposed to the moisture necessary for corrosion reactions to proceed. The electrochemical processes that cause steel to rust, oxidation at anodic sites, oxygen reduction at cathodic sites, ionic current flow through the electrolyte provided by moist concrete, could now operate throughout the building's structural frame. The corrosion of reinforcing steel in concrete produces iron oxides that occupy significantly greater volume than the original steel. The expansive pressure generated by this volume increase creates tensile stresses in the surrounding concrete. Concrete, strong in compression, is weak in tension. It cracks when tensile stresses exceed its modest tensile strength. Once cracking occurs, moisture and oxygen have easier access to the reinforcement, accelerating corrosion. Additional rust forms, creating additional expansion, propagating cracks further. This self-reinforcing cycle continues until the concrete cover spalls off entirely, exposing reinforcement to even more aggressive corrosive conditions. The visible manifestation of this process appeared on Michigan Central's structure throughout the 1990s and 2000s. Rust staining, the migration of corrosion products to concrete surfaces, indicated locations where internal corrosion was active. Cracking patterns aligned with reinforcement positions revealed where expansive pressures were developing. Spalled concrete, falling from columns, beams, and floor slabs, demonstrated where the process had advanced to structural damage. Each exposure of reinforcement to direct atmospheric conditions accelerated corrosion at that location, while the damage created pathways for moisture to reach additional reinforcement deeper in the structure. The building's floor systems proved particularly vulnerable to corrosion-induced damage. Floor slabs in early reinforced concrete construction typically featured relatively thin sections with shallow reinforcement cover, design choices driven by economy and the limited span requirements of the column grid. These thin slabs reached carbonation depths quickly, and once moisture became available, experienced corrosion damage faster than more massive structural elements. The progressive failure of floor slabs throughout the tower threatened not only the slabs themselves, but the structural elements supporting them, as falling debris and differential settlements created stress concentrations that the original design had not anticipated. Freeze-thaw damage operated in parallel with corrosion, attacking both concrete and masonry elements throughout the building. Water that penetrates porous materials and then freezes exerts mechanical pressure on the material's internal structure. The crystallization pressure of ice, forming in confined spaces, can exceed the tensile strength of concrete, stone, and brick, causing cracking that allows additional water penetration in subsequent cycles. Southern Michigan's climate produces ideal conditions for freeze-thaw damage, adequate precipitation to saturate materials, temperatures that fluctuate across the freezing point frequently throughout winter, and sufficient cold periods to allow ice formation deep within material sections. The building's exterior terracotta ornament experienced severe freeze-thaw damage during the vacancy period. Terracotta, as a fired clay product, contains an inherently porous microstructure that readily absorbs water. The ornamental elements on Michigan Central's facades had been exposed to weather since 1913, but the controlled interior conditions and occasional maintenance of the occupied period had limited moisture accumulation. Vacancy changed this equation dramatically. Water penetrated from multiple directions, through failed glazing behind terracotta panels, through cracks that developed in mortar joints, through the terracotta body itself. This water then froze repeatedly, progressively degrading the material until pieces began separating from the building. The anchoring systems that secured terracotta elements to the building's structure experienced parallel deterioration. These anchors, typically made of ferrous metal, corroded when exposed to moisture, Corroding anchors expanded, cracking the terracotta from within. They also lost cross-sectional area and strength, eventually becoming unable to support the weight of the elements they were designed to secure. Terracotta pieces that had remained attached for 8 decades began falling from the building's facades, creating safety hazards that required protective barriers and further isolating the structure from any productive use. The stone elements incorporated in the building's construction, limestone base courses, granite steps, marble interior finishes, experienced different but equally damaging deterioration processes. Limestone and marble, both calcium carbonate materials, are susceptible to dissolution by acidic precipitation. The industrial atmosphere of Detroit, while improved from its most polluted period, still contained enough acidic compounds to attack carbide stone surfaces. More significantly, these materials are also susceptible to freeze-thaw damage when saturated. The interior marble surfaces, protected from weather during occupied operation, were now exposed to moisture infiltration from failed roof and envelope systems. Freeze-thaw cycling caused surface spalling, exfoliation, and eventually structural cracking in marble elements throughout the building. The wood elements that remained in the building after salvage, window frames, interior doors, trim, structural blocking, and remnants of built-in furnishings, experienced accelerated decay under vacancy conditions. Wood is a hygroscopic material that reaches moisture equilibrium with its environment. In the controlled humidity of occupied buildings, this equilibrium typically occurs at moisture contents below the threshold required for decay fungi to colonize. Vacancy eliminated humidity control, and moisture infiltration from envelope failures created conditions where wood elements frequently exceeded the approximately 20% moisture content threshold for fungal activity. Decay organisms that had been unable to establish themselves during occupied operation now colonized wood elements throughout the building, causing strength loss and eventual structural failure. The interaction between different deterioration mechanisms created damage patterns more severe than any single mechanism would have produced alone. Corrosion-induced cracking in concrete opened pathways for moisture that accelerated freeze-thaw damage. Freeze-thaw cracking increased the permeability of materials, allowing deeper carbonation penetration and faster corrosion initiation at greater depths. Failed stone and terracotta created envelope breaches that increased moisture loading on interior materials. Wood decay weakened elements that had been providing structural support to masonry, causing additional cracking and displacement. Each deterioration mechanism created conditions that accelerated other mechanisms, producing a system-wide failure process that compounded over time. The spatial distribution of damage throughout the building reflected the specific pathways by which destructive agents reached vulnerable materials. Damage was most severe at locations where water intrusion was greatest, beneath roof failures, adjacent to broken windows, at floor levels where ponding occurred. The upper levels of the tower, exposed to greater wind-driven moisture and more severe thermal cycling, deteriorated faster than lower levels. Interior spaces closest to envelope breaches experienced damage first, with deterioration progressing inward as moisture migrated through the building fabric. The pattern of damage told a physical story of water as the primary destructive agent, enabled by envelope failure and amplified by thermal cycling. The mechanical, electrical, and plumbing systems that had served the building during its operational life were effectively destroyed during the vacancy period. Piping systems, drained to prevent freeze damage, nevertheless experienced corrosion from residual moisture and atmospheric exposure. Electrical wiring insulation degraded, creating fire hazards that would require complete system replacement before the building could be occupied. Heating equipment, having sat idle for years in an uncontrolled environment, deteriorated beyond any possibility of reactivation. The elevator systems that had provided vertical circulation in the tower were particularly vulnerable. Their mechanical components corroded, their electrical controls became obsolete, their shafts filled with debris from deteriorating shaft walls. Any rehabilitation of the building would require not merely repair of these systems, but complete replacement with modern equipment meeting current code requirements. The structural frame that had been Michigan Central's most durable element eventually showed signs of distress that raised questions about continued stability. While the building was never at imminent risk of collapse, the original design included substantial safety factors and reinforced concrete frames are highly redundant structural systems. The cumulative effect of decades of deterioration had reduced structural capacity in ways that were difficult to quantify without extensive investigation. Floor slabs that had lost significant reinforcement due to corrosion could no longer safely support their design loads. Columns with spalled concrete and exposed, corroded reinforcement had reduced capacity. Beams experiencing differential corrosion damage might develop unexpected deflections or cracking patterns. The structural uncertainty created by decades of uncontrolled deterioration added yet another layer of cost and complexity to any rehabilitation effort. By the early 2000s, Michigan Central Station had reached a physical condition that defied simple characterization. The building was not a ruin in the classical sense. Its walls still stood, its roof still existed, its basic form remained recognizable, but it was no longer a building in any functional sense. The interior had been gutted by a combination of salvage, vandalism, water damage, and biological colonization. The envelope that separated interior from exterior had been so thoroughly compromised that the distinction was largely meaningless. The structural frame, while still standing, had experienced damage of unknown extent that would require expensive investigation to characterize. The building existed in a liminal state between structure and ruin, preserved from complete destruction by the durability of its original construction, but rendered uninhabitable by the accumulation of 3 decades of uncontrolled deterioration. The physical processes that had brought Michigan Central to this condition would continue operating regardless of any human decision about the building's future. Concrete carbonation would advance, steel corrosion would progress, freeze-thaw cycling would continue through each Michigan winter. Water would continue penetrating through every breach in the building envelope. The trajectory of deterioration was not reversible. Damage that had occurred could not be undone, only repaired or replaced. But the rate of future deterioration could be influenced by intervention. Stabilization measures could slow the progression. Envelope repairs could reduce moisture loading. Structural repairs could arrest corrosion and restore lost capacity. The building's survival now depended entirely on whether any institution would commit the resources necessary to interrupt physical processes that had been operating unchecked for 15 years. The mathematics of deterioration pointed toward an eventual threshold beyond which preservation would become impossible by any practical standard. Each year of continued neglect added to the scope of required repairs. Each year reduced the proportion of original fabric that could be retained. At some point, difficult to specify precisely but certain to arrive, the cost of rehabilitation would exceed the cost of demolition and new construction, eliminating any economic rationale for preservation. At some further point, the extent of deterioration would make preservation technically impractical regardless of cost, as too little original fabric would remain to constitute a meaningful historic resource. Michigan Central Station was advancing steadily toward these thresholds, its survival dependent on intervention that showed no sign of materializing. The deterioration of Michigan Central Station did not proceed unobserved. Throughout the 1990s and 2000s, the building's condition attracted attention from preservation advocates, real estate developers, municipal officials, and the general public. The station's prominent location, its architectural significance, and its potent symbolism as an emblem of Detroit's decline ensured that its fate remained a subject of ongoing discussion and periodic intervention. What these discussions and interventions consistently failed to produce was a viable path to rehabilitation. The gap between what preservation required and what any plausible owner could provide proved unbridgeable through conventional means, and each failed attempt to bridge that gap extended the vacancy period that was destroying the building. The earliest serious preservation efforts emerged in the immediate aftermath of Amtrak's departure. Local preservation organizations recognized that the station's vacancy represented a critical threat and advocated for immediate stabilization measures. These advocates understood, at least in general terms, that uncontrolled vacancy would cause accelerating damage and that early intervention would be far more cost-effective than delayed action. Their recommendations: secure the building against unauthorized entry, maintain minimal heating to prevent freeze damage, repair the most critical envelope failures, implement regular inspection and maintenance protocols, represented sound preservation practice that could have significantly slowed the building's deterioration trajectory. These recommendations were not implemented, for reasons that illuminated the institutional vacuum surrounding the property. The building's owner at the time of closure was a successor entity to the Penn Central Bankruptcy Estate, an organization with neither the resources nor the mandate to invest in preservation. Transferring ownership to a more capable steward required identifying a buyer willing to accept the liabilities associated with a deteriorating historic property. No such buyer materialized. The building was not generating income and could not be expected to generate income without substantial investment. Any purchaser would inherit not only the building but the accumulated deferred maintenance of decades, environmental contamination requiring remediation, and code compliance obligations that would multiply rehabilitation costs. The property was, in conventional real estate terms, a liability rather than an asset. The city of Detroit, which might have intervened to protect a significant architectural resource within its boundaries, faced constraints that precluded meaningful action. Detroit's municipal finances had been deteriorating for decades, paralleling the decline of the industries that had once made it America's fourth-largest city. The city government struggled to provide basic services, police, fire, sanitation, to its remaining residents. Investing municipal resources in preserving an abandoned railroad station, however architecturally significant, was politically impossible when schools were underfunded and neighborhoods lacked streetlights. The city's Historic Preservation Office could designate the building as a local landmark and impose restrictions on demolition, but it could not compel private owners to maintain their properties or provide public funding for rehabilitation. The state of Michigan similarly lacked mechanisms to address Michigan Central's predicament. State historic preservation programs focused primarily on documentation, technical assistance, and administration of federal tax credit programs. These programs could facilitate private investment in historic properties, but could not substitute for such investment when private capital was unavailable. The state had no dedicated funding source for preserving endangered landmarks and no statutory authority to acquire private property for preservation purposes absent owner consent. Michigan Central Station fell outside the boundaries of any state park or historic site that might have justified direct state stewardship. Federal programs offered somewhat greater resources, but imposed requirements that proved difficult to satisfy. The Federal Historic Preservation Tax Credit, which had facilitated rehabilitation of thousands of historic buildings nationally, provided a 20% credit against federal income tax liability for qualified rehabilitation expenditures on income-producing properties listed on the National Register of Historic Places. Michigan Central Station was listed on the National Register, making it theoretically eligible for these credits. But claiming the credits required a substantial rehabilitation investment generating taxable income against which credits could be applied. A project that could not attract sufficient private investment to proceed could not generate tax liability and therefore could not benefit from tax credits. The credits facilitated projects that were marginally feasible. They could not rescue projects that were fundamentally uneconomic. The sequence of development proposals that emerged during the 1990s illustrated the persistent gap between Michigan Central's rehabilitation requirements and achievable project economics. The first serious proposal, advanced in the early 1990s, envisioned converting the station into a hotel and conference center. The concept had surface plausibility. The building's grand public spaces could accommodate conference functions, the tower could provide guest rooms, and the facility's historic character could differentiate it from conventional hotels. Preliminary cost estimates suggested rehabilitation might be achievable for approximately $80 million, a substantial sum but not unprecedented for a project of this scale and complexity. The proposal failed when detailed analysis revealed that achievable room rates and occupancy levels in the Detroit market could not support debt service on an $80 million investment. The Detroit hotel market in the early 1990s was oversupplied and weak, with existing hotels struggling to maintain occupancy and average daily rates. A rehabilitated Michigan Central station, however distinctive, could not command rate premiums sufficient to offset its elevated development costs. The project pro forma showed operating deficits rather than returns, making private financing impossible and public subsidy levels unrealistic. The proposal was abandoned without breaking ground. Subsequent proposals during the 1990s explored alternative uses: casino, mixed-use development, transportation hub, corporate headquarters, each confronting variations of the same fundamental problem. Rehabilitation costs were driven by the building's physical condition, its architectural complexity, and applicable code requirements. These costs could not be significantly reduced without compromising the historic character that made the building worth preserving. Achievable revenues were constrained by Detroit's struggling real estate market, which offered neither the rental rates nor the absorption capacity that ambitious development programs required. The gap between costs and revenues represented a structural economic problem that creative programming could not solve. Each failed proposal extended the vacancy period and allowed additional deterioration to occur. The building's condition in 1995 was worse than its condition in 1990. Its condition in 2000 was worse than its condition in 1995. With each passing year, rehabilitation cost estimates increased as the scope of required repairs expanded. A project that might have been marginally feasible in 1990 became increasingly infeasible as deterioration progressed. The gap between rehabilitation cost and achievable value was not static. It widened continuously as the building's condition declined. The ownership of Michigan Central Station changed hands multiple times during the 1990s and 2000s, but none of the successive owners possessed both the resources and the commitment to undertake rehabilitation. The building was transferred through foreclosure proceedings, sold at distressed prices, and traded between speculative investors who hoped to profit from eventual redevelopment without investing in interim preservation. Each ownership transfer reset planning processes and introduced new actors unfamiliar with the building's history and condition. The institutional knowledge that might have informed effective intervention was never accumulated, as owners and their advisors cycled through without maintaining continuity. Manuel Moron, a transportation entrepreneur who had assembled a significant real estate portfolio in the Detroit-Windsor corridor, acquired Michigan Central Station in 1995. Moron's holdings included the Ambassador Bridge, the busiest international border crossing in North America, as well as substantial commercial and industrial properties in the surrounding area. His acquisition of Michigan Central appeared to signal the possibility of investment by an owner with substantial resources and long-term presence in the market. Initial statements suggested that Moron intended to rehabilitate the building, though specific plans and timelines remained vague. The rehabilitation that Moron's statements implied did not materialize. The building continued deteriorating throughout the late 1990s and 2000s under his ownership. Minimal security measures were implemented: fencing around the perimeter, periodic patrols, boarding of accessible openings, But comprehensive stabilization was not undertaken. The roof continued to fail. Water continued penetrating the interior. Freeze-thaw cycling continued damaging concrete and masonry. The ornamental plaster continued falling from the waiting room ceiling. Whatever Moron's initial intentions, the resources required for preservation exceeded what he was willing or able to commit. The reasons for Moron's failure to invest in Michigan Central's preservation remained somewhat opaque, as his organizations did not publicly explain their decision-making. Speculation focused on several possibilities. The rehabilitation economics that had defeated earlier proposals remained unfavorable, and Moron may have concluded that no feasible development program existed. The building's deteriorated condition may have exceeded his initial expectations, causing cost estimates to escalate beyond anticipated levels. His primary business interests lay in transportation infrastructure rather than real estate development, and Michigan Central may have represented a distraction from more profitable opportunities. Alternatively, he may have been holding the property for speculative purposes, betting that eventual market improvement or public investment would create value that he could capture without committing his own capital to rehabilitation. Public frustration with the building's continued deterioration intensified during the 2000s. Michigan Central Station had become an internationally recognized symbol of Detroit's decline, featured in countless photographs, documentaries, and articles about American urban decay. The building's ruinous condition was cited by critics as evidence of Detroit's dysfunction, its inability to preserve even its most significant architectural heritage. Preservation advocates, architectural historians, and civic leaders called repeatedly for action to save the building, though none could specify who would pay for such action or how the fundamental economics of rehabilitation could be made to work. The tension between preservation aspirations and economic reality reached a critical point in 2009, when the City of Detroit's Planning Department proposed demolishing Michigan Central Station. The proposal reflected an assessment that the building was beyond practical rehabilitation and that its continued presence blighted the surrounding neighborhood. Demolition would remove a visible symbol of decline and could clear the site for potential redevelopment. The cost of demolition, while substantial given the building's scale, was far less than the cost of rehabilitation. From a narrow fiscal perspective, demolition appeared to represent the most efficient resolution of a problem that had defied solution for 2 decades. The demolition proposal generated immediate and intense opposition. Preservation organizations mobilized nationally to oppose the destruction of a building they considered architecturally significant at the national level. Architectural historians documented Michigan Central's importance as one of the finest surviving examples of Beaux-Arts railroad terminal design. Local advocates argued that demolition would represent capitulation to decline rather than a step toward recovery, eliminating an irreplaceable historic resource that could anchor future revitalization. The opposition was effective. The demolition proposal was withdrawn without action, and Michigan Central Station remained standing. The preservation of Michigan Central through the 2009 demolition threat demonstrated that sufficient political will existed to prevent the building's destruction. What remained absent was the mechanism to translate preservation sentiment into preservation action. The same advocates who successfully opposed demolition could not identify a path to rehabilitation. The building survived not because anyone had solved the problem of its preservation, but because the alternative of demolition was deemed unacceptable. This was preservation by default, rather than by design, and it offered no solution to the ongoing deterioration that continued reducing the building's chances of ultimate survival. The following years brought additional deterioration and additional failed initiatives. Various proposals for adaptive reuse circulated without attracting the investment necessary for implementation. Minimal stabilization measures were occasionally undertaken, but comprehensive preservation remained beyond reach. The building's physical condition continued declining, though perhaps more slowly than during the 1990s as the most vulnerable elements had already been destroyed. Michigan Central Station had reached a kind of equilibrium, too significant to demolish, too deteriorated to rehabilitate through conventional means, too expensive to maintain properly, and too prominent to ignore. The cumulative effect of 30 years of failed preservation attempts was to transform Michigan Central from a building requiring rehabilitation into a building requiring rescue. The investments that might have succeeded in 1988 or 1995 would no longer suffice. The deterioration that had occurred was not merely quantitatively greater than earlier periods, but qualitatively different. Original fabric that could have been repaired now required replacement. Systems that could have been upgraded now required complete reconstruction. The proportion of the building that could be meaningfully preserved had diminished with each passing year. Rehabilitation had become reconstruction, and the costs had escalated accordingly. By 2015, credible estimates placed the cost of comprehensive rehabilitation at $300 million or more, roughly 4 times the estimates that had circulated in the early 1990s. This figure exceeded any plausible private investment return in the Detroit real estate market. It exceeded the capacity of federal and state historic preservation programs. It exceeded the fiscal resources of a city that would shortly enter the largest municipal bankruptcy in American history. The gap between rehabilitation cost and available resources had grown from a challenge to an impossibility, at least through the mechanisms that had preserved thousands of other historic buildings across the country. Michigan Central Station's preservation, if it was to occur at all, would require intervention by an actor operating outside conventional real estate economics. It would require resources measured in hundreds of millions of dollars. It would require tolerance for financial returns that private investors would consider unacceptable. It would require commitment sustained over years of construction and decades of operation. Such actors existed: major corporations, sovereign wealth funds, philanthropic foundations, but their interests had never previously aligned with Michigan Central's preservation. The building's survival now depended entirely on whether such an alignment might somehow be achieved. The announcement came on June 19, 2018, in a press event staged within the very building whose fate it would determine. Ford Motor Company, the industrial enterprise that had shaped Detroit's identity as profoundly as any institution in American history, declared its intention to acquire Michigan Central Station and transform it into the centerpiece of a new innovation campus. The company would purchase the station and surrounding properties from the Moran family, invest hundreds of millions of dollars in comprehensive rehabilitation, and establish a research and development center focused on autonomous vehicles, electric propulsion, and urban mobility solutions. After 30 years of vacancy, failed proposals, and accelerating deterioration, Michigan Central Station had found an owner with both the resources and the commitment to ensure its survival. The Ford announcement represented a convergence of corporate strategy, civic aspiration, and historical circumstance that no planning process had anticipated. Ford's interest in Michigan Central did not emerge from preservation sentiment or real estate investment logic. It emerged from the company's strategic assessment of its competitive position in an automotive industry undergoing fundamental transformation. The technologies that would define transportation's future, autonomous driving systems, electric powertrains, connectivity platforms, mobility services, required capabilities and talent that Ford's existing facilities and workforce could not fully provide. The company needed to establish a presence in the innovation ecosystem, attract software engineers and data scientists accustomed to working in urban environments, and project an image of technological leadership that would resonate with customers, investors, and potential employees. Michigan Central Station, despite its ruinous condition, offered attributes that purpose-built facilities could not replicate. Its architectural character communicated permanence, ambition, and connection to Detroit's industrial heritage. Its location in Corktown, adjacent to downtown Detroit, placed it within the urban environment that technology workers increasingly preferred. Its scale provided sufficient space for the research facilities, collaboration spaces, and amenity functions that a modern innovation campus required. Its rehabilitation would generate publicity and goodwill that no marketing campaign could match. The building's very dereliction had made it famous. Transforming it into a showcase of technological innovation would complete a narrative arc from industrial decline to technological renewal that would resonate globally. Ford's decision to acquire Michigan Central represented a corporate investment rather than a real estate investment. The distinction was crucial. A real estate investor evaluates properties based on their ability to generate financial returns through rental income, appreciation, or eventual sale. By this standard, Michigan Central Station remained what it had always been during its vacancy period, an economically irrational investment whose rehabilitation costs far exceeded any achievable market returns. Ford was not acquiring the building as a real estate investment. The company was acquiring it as a strategic asset whose value would be realized through its contribution to Ford's broader business objectives rather than through direct financial returns from the property itself. This strategic framework transformed the economics of rehabilitation. A real estate investor seeking market-rate returns could not justify $300 million or more in rehabilitation expenditure for a building that might generate $20 million in annual rental income. Ford, by contrast, could justify the investment if it contributed to competitive advantages worth far more than the rehabilitation cost. If Michigan Central helped Ford attract the talent necessary to compete in autonomous vehicles, if it enhanced the company's reputation as a technology leader, if it facilitated collaboration with partners and suppliers, if it strengthened relationships with the city of Detroit and the state of Michigan, these benefits, though difficult to quantify precisely, could easily exceed the rehabilitation investment over the facility's useful life. The acquisition agreement announced in June 2018 encompassed not only Michigan Central Station, but also the former Detroit Public Schools book depository, the former brass factory on Michigan Avenue, and additional parcels that would form a 30-acre campus. The total investment that Ford projected for the campus development exceeded $740 million, with the station rehabilitation representing the largest single component. This investment scale was unprecedented for a historic rehabilitation project in Detroit and among the largest such projects in American history. It exceeded by a factor of 3 or more the estimates that had circulated during earlier failed development attempts, reflecting both the escalation of costs during the extended vacancy period and Ford's comprehensive vision for the facility. The rehabilitation scope that Ford's architects and engineers defined reflected the full extent of damage that 30 years of vacancy had inflicted. The building's exterior envelope required comprehensive restoration, every window replaced, all terracotta and stonework repaired or replicated, the entire roof reconstructed. The structural frame required extensive concrete repair, reinforcement supplementation, and capacity upgrades to accommodate modern occupancy loads. The interior, stripped of virtually all original finishes by a combination of water damage, vandalism, and salvage, would be reconstructed using historical photographs and surviving documentation as guides. All mechanical, electrical, and plumbing systems would be replaced with modern equipment meeting current codes and Ford's operational requirements. The window replacement program alone illustrated the scale of intervention required. Michigan Central Station contained approximately 1,050 windows across its tower and head house, virtually all of which had been destroyed during the vacancy period. Replacing these windows required not merely purchasing standard commercial products, but designing and fabricating custom units that replicated the appearance of the original wood sash while meeting contemporary performance requirements for thermal efficiency, structural capacity, and life safety. Each window opening had to be measured individually, as decades of structural movement had caused dimensional variations that precluded standardized manufacturing. The cost of window replacement alone approached $50 million. The structural rehabilitation program addressed the corrosion damage, concrete deterioration, and capacity deficiencies that 30 years of exposure had created. Engineers conducted comprehensive surveys of the building's structural elements, mapping the location and extent of damage through visual inspection, material testing, and non-destructive evaluation techniques. The surveys revealed widespread corrosion of reinforcing steel, particularly in floor slabs and exterior columns where moisture exposure had been greatest. Concrete cover had spalled from significant portions of the structural frame. Load testing indicated that some floor areas could no longer safely support design occupancy loads without reinforcement. The repair protocols that engineers developed addressed each type of damage with appropriate interventions. Corroded reinforcement was cleaned of rust products and treated with corrosion inhibitors. Lost concrete cover was replaced with repair mortars designed for compatibility with the original materials. Supplemental reinforcement was added where capacity had been compromised. Structural steel was installed to support loads that the original concrete system could no longer carry. Carbon fiber reinforcement was applied to strengthen floor slabs without adding significant weight. The cumulative effect of these interventions was to restore structural capacity while preserving as much original fabric as feasible. The interior reconstruction program recreated spaces that had been destroyed beyond meaningful repair. The waiting room, whose ornamental plaster ceiling had largely collapsed during the 1990s, was reconstructed using photographic documentation and surviving fragments as references. Skilled plasterers, the same craftsmen whose absence had made proper maintenance impossible during the building's decline, were engaged to execute ornamental work using traditional techniques. The terracotta floor tiles that had characterized the original waiting room were replicated by manufacturers capable of matching the historic materials. Bronze fixtures and hardware were either conserved where salvageable or replicated where destroyed. The mechanical systems installed in the rehabilitated building bore no relationship to those that had served the original structure. Modern heating, ventilation, and air conditioning systems replaced the steam-based systems of 1913. Contemporary electrical distribution replaced the original knob and tube wiring. Digital building automation systems provided monitoring and control capabilities that the original operators could not have imagined. Fire suppression, security, and life safety systems were installed throughout, bringing the building into compliance with current codes and Ford's corporate standards. The building's infrastructure was entirely contemporary, even as its appearance evoked the Beaux-Arts splendor of its origins. The rehabilitation program extended beyond the building itself to address the surrounding site and urban context. New construction on adjacent parcels would provide additional workspace, parking structures, and amenity facilities that the historic building could not accommodate. Landscape improvements would connect the campus to the Corktown neighborhood and create pedestrian-friendly environments. Infrastructure upgrades would address decades of deferred investment in streets, utilities, and public spaces. Ford's investment was reshaping not merely a single building, but an entire district, catalyzing complementary investment that was already transforming Corktown from a struggling neighborhood into one of Detroit's most desirable locations. The financing structure that Ford assembled for the project drew on multiple sources, reflecting the rehabilitation's multiple stakeholders. Ford's direct corporate investment represented the largest component, funded from the company's substantial cash reserves and capital budget. Federal Historic Preservation Tax Credits, the same program that had proven insufficient to enable earlier rehabilitation attempts, provided meaningful, though not decisive, support. The credits worked in combination with Ford's corporate investment rather than substituting for absent private capital. State of Michigan incentives, negotiated as part of the acquisition agreement, provided additional public contribution. The City of Detroit contributed through tax increment financing and other economic development tools. The combined effect was a financing structure that distributed costs across public and private sources in proportions that reflected the project's multiple beneficiaries. The public contribution to Michigan Central's rehabilitation raised questions about appropriate public investment in private facilities. Critics argued that Ford, one of America's largest and most profitable corporations, should not require public subsidy to develop its own campus. Supporters countered that the public benefits of the project, job creation, neighborhood revitalization, preservation of a significant landmark, tax revenue generation, justified public investment, even when the primary beneficiary was a private company. The debate echoed similar discussions surrounding major development projects across the country, reflecting unresolved tensions about the appropriate relationship between public resources and private economic activity. The rehabilitation construction proceeded from 2018 through 2023, transforming Michigan Central Station from ruin to showpiece over 5 years of intensive work. The construction workforce numbered in the hundreds at peak activity, representing trades ranging from ironworkers and concrete masons to ornamental plasterers and bronze conservators. The project provided employment opportunities for Detroit residents and training opportunities for workers seeking skills in historic preservation. It demonstrated that the specialized craft knowledge necessary for maintaining historic buildings, while rare, could still be assembled when sufficient resources were committed. Ford's completed campus opened in phases beginning in 2022, with the station building substantially complete by 2023. The rehabilitated structure housed research and development functions focused on Ford's mobility initiatives, along with collaboration spaces, event facilities, and amenities serving campus occupants. The waiting room, restored to an approximation of its original grandeur, served as a public event space available for community functions. The tower, gutted and rebuilt with contemporary office interiors, provided workspace for hundreds of Ford employees and partners. The building that had spent 30 years as Detroit's most prominent ruin now served as a symbol of the city's potential for renewal. The lessons embedded in Michigan Central's trajectory extended far beyond the specifics of this particular building or this particular rescue. The station's 30-year decline demonstrated that historic buildings require institutional stewardship, not merely regulatory protection. Landmark designation prevented demolition, but could not compel maintenance or investment. Tax credit programs facilitated rehabilitation where market conditions were favorable, but could not bridge fundamental economic gaps. Preservation advocacy generated political support for protection, but could not generate the capital necessary for preservation. The building survived ultimately because a corporation with strategic objectives aligned with preservation happened to identify it as valuable for reasons unrelated to its historic significance. The dependence of Michigan Central's survival on this fortuitous alignment exposed the fragility of preservation mechanisms that assumed market forces would protect significant resources. Michigan Central was not saved by the preservation system. It was saved by circumstances that the preservation system neither created nor controlled. Other significant buildings facing similar economic challenges could not expect similar rescues. The Ford acquisition represented an exceptional outcome, not a replicable model. The systemic lessons that Michigan Central's trajectory offered pointed toward mechanisms that did not currently exist: dedicated preservation endowments, public acquisition authorities, maintenance requirements with enforcement mechanisms, rather than toward confidence in existing frameworks. The physical evidence revealed during rehabilitation confirmed the deterioration trajectories that engineers had predicted. Concrete damage was extensive, but not total. The building's original structural system, conservatively designed with substantial safety factors, had retained enough capacity to permit rehabilitation rather than requiring demolition and reconstruction. Corrosion damage, while severe in some locations, had not progressed to structural failure. The envelope deterioration, though comprehensive, had not undermined the fundamental stability of walls and roof structures. The building had reached a condition where another decade or two of neglect might have pushed it beyond the threshold of practical rehabilitation, but it had not yet crossed that threshold. The Ford intervention came late, but not too late. Michigan Central Station's transformation from ruin to innovation hub completed a narrative arc that began with the embedded assumptions of its 1913 designers. Those designers had created a monument to permanence in an industry and a city that would prove far less permanent than they imagined. The assumptions encoded in the building's scale, cost structure, and revenue model had made its abandonment inevitable once the conditions they anticipated failed to materialize. The institutional frameworks that governed railroad management, preservation policy, and urban development had proven incapable of preventing or reversing the building's decline. Only intervention from outside those frameworks, corporate investment driven by strategic objectives unrelated to the building's intrinsic economics, had enabled the building's survival. The station that opened in 1913 was designed to serve a future that never arrived. The station that reopened in 2023 was designed to create a future that its rescuers hoped would prove more enduring. Whether Ford's autonomous vehicle research would transform transportation as profoundly as the railroads once had, whether the Corktown campus would generate the innovation its designers envisioned, whether Michigan Central Station would remain a vital facility or eventually face another cycle of obsolescence, these questions could not be answered from the vantage point of completion. What could be observed was that a building designed for one vision of permanence had survived to serve another, rescued from destruction not by the systems intended to protect it, but by historical contingency and corporate strategy. The dark story behind Michigan Central Station was not ultimately a story of vandalism or neglect or municipal dysfunction. It was a story of design assumptions that could not accommodate change, institutional frameworks that could not preserve what they valued, and physical processes that operated regardless of human intentions. The building survived, but its survival offered no guarantee that other buildings facing similar challenges would find similar rescues.